About Swift, understand the high-level goals of the language. Swift is a fantastic way to write software, whether it's for phones, desktops, servers, or anything else that runs code. It's a safe, fast, and interactive programming language that combines the best of modern language thinking with wisdom from the wider Apple engineering culture and the diverse contributions from its open source community. The compiler is optimized for performance and the language is optimized for development, without compromising on either. Swift is friendly to new programmers. It's an industrial quality programming language that's as expressive and enjoyable as a scripting language. Writing Swift code in a playground lets you experiment with code and see the result immediately, without the overhead of building and running an app. Swift divides away large classes of common programming errors by adopting modern programming patterns. Variables are always initialized before use. Array indices are checked for out-of-bounds errors. Integers are checked for overflow. Optionals ensure that nil values are handled explicitly. Memory is managed automatically. Error handling allows controlled recovery from unexpected failures. Swift code is compiled and optimized to get the most out of modern hardware. The syntax and standard library have been designed based on the guiding principle that the obvious way to write your code should also perform the best. Its combination of safety and speed make Swift an excellent choice for everything from Hello World to an entire operating system. Swift combines powerful type inference and pattern matching with a modern lightweight syntax, allowing complex ideas to be expressed in a clear and concise manner. As a result, code is not just easy to write, but easy to read and maintain as well. Swift has been years in the making, and it continues to evolve with new features and capabilities. Our goals for Swift are ambitious. We can't wait to see what you create with it. Version compatibility. Learn what functionality is available in all the language modes. This book describes Swift 5.8, the default version of Swift that includes in Xcode 14. You can use Xcode 14 to build targets and that are written in either Swift 5.8 or Swift 4.2 or Swift 4. When you use Xcode 14 to build Swift 4 and Swift 4.2 code, most Swift 5.8 functionality is available. That said, the following changes are available only to code that uses Swift 5.8 or later. Functions that return an OPAC type require the 5.1 runtime. Swift 5.1 runtime. The try optional expression doesn't introduce an extra level of optionality to expressions that already return options. Large integer literal initialization expressions are inferred to be out of the correct integer type. For example, uint640xfffff underscore ffff underscore ffff underscore fffff evaluates to the correct value rather than overflowing. Concurrency requires 5.8 or later, and a version of the Swift standard library that provides corresponding concurrency types. On Apple platforms set the deployment targets of at least iOS 13, macOS 10.15, tvOS 13, or watchOS 6. A target written in Swift 5.8 can depend on a target that's written in Swift 4.2 or Swift 4, and vice versa. This means if you have a large project that's divided into multiple frameworks, you can migrate your code from Swift 4 to Swift 5.8, one framework at a time. A Swift tour. Explore the features and syntax of Swift. Tradition suggests that the first program in a new language should print the words Hello World on the screen. In Swift, this can be done in a single line. Print Hello World, print Hello World. If you have written code in C or Objective-C, this syntax looks familiar to you. In Swift, this line of code is a complete program. You don't need to import a separate library for functionality like input, output, or string handling. Code written at a global scope is used as the entry point for a program, so you don't need the main function. You also don't need to write semicolons at the end of every statement. This talk gives you enough information to start writing code in Swift by showing you how to accomplish a variety of programming tasks. Don't worry if you don't understand something. Everything introduced in this talk is explained in detail at the rest of this book. Simple values. Use let to make a constant and var to make a variable. The value of a constant doesn't need to be known at compile time, but you must assign it a value exactly once. This means you can use constants to name a value that you determine once, but use in many places. My variable is 42. My variable is 50. Let my constant is 42. A constant or variable must have the same type as the value you want to assign to it. However, you don't always have to write providing a value when you create the constant or variable lest the compiler infer its type. In the example above, the compiler infers that my variable is an integer because its initial value is an integer. If the initial value doesn't provide enough information, or if there isn't an initial value, specify the type by writing it after the variable, separated by a colon. Let implicit integer is 70. Let implicit double is 70.0. Let explicit double is of type double is 70. Experiment. Create a constant with an explicit type of float and a value of 4. Values are never implicitly converted to another type. If you don't need to convert the value to a different type, explicitly make an instance of the desired type. Let label is, between quotes, the width is. Let width is 94. Let width label is label plus string, parentheses width. Experiment. Try removing the conversion to string from the last line. What error do you get? There is an even simpler way to include values in strings. Write the value in parentheses and write the backslash before the parentheses. For example, let apples is 3, let orange is 5, let apple summary is I have backslash parentheses apples and quotes. Let fruit summary is I have apples plus oranges pieces of fruit. Experiment. Use the backslash and parentheses to include the floating point calculation in the string and to include someone's name in the greeting. Use 3 double quotation marks for strings that take up multiple lines. Indentation at the start of each quoted line is removed, as long as it matches the indentation of the closing quotation marks. For example, let quotation, even though there's a white space to the left, the actual lines aren't intended, except for this line. Double quotes can appear without being escaped. I still have backslash parentheses apple plus oranges pieces of fruit. Create arrays and dictionaries using brackets and parentheses and access their elements by writing the index or key in brackets. A comma is allowed after the last element. Var fruits, strawberries, limes, tangerines. Fruits brackets 1 is grapes. Var occupation brackets Malcolm is a colon captain. Kaylee colon mechanic. And bracket occupations Jane bracket public relations. Arrays automatically grow as you add elements. You also use brackets to write an empty array or dictionary for an array. Write brackets, and for a dictionary write brackets colon. If you're assigning an empty array or dictionary to a new variable or another place where there isn't any type information, you need to specify the type. Control flow. Use if and switch to make conditionals, and use for in while, and repeat while to make loops. Parentheses around the condition or loops variable are optional. Braces around the body are required. If an if statement, the conditional must be a Boolean expression. This means that the code as if score is an error, not an implicit comparison to 0. You can use if and let together to work with values that might be missing. These values are represented as optionals. An optional value either contains a value or contains nil to indicate that the value is missing. Write the question mark after the type of a value to mark the value as an optional. Experiment. Change the optional name to nil. What greeting do you get? Add an else clause that sets a different greeting if optional name is nil. If the optional value is nil, the conditional is false, and the code in braces is skipped. Otherwise, the optional value is unwrapped and assigned to the constant after the let, which makes the unwrapped value available inside the block of code. Another way to handle optional values is to provide the default value using double question marks operator. If the optional value is missing, the default value is used instead. You can use a shorter spelling to unwrap a value using the same name for that unwrapped value. Switches support any kind of data and a wide variety of comparison operations. They aren't limited to integers and tests for equality. Experiment. Try removing the default case. What error do you get? Notice how let can be used in a pattern to assign a value that matches the pattern to a constant. After executing the code inside the switch case that matched, the program exits from the switch statement. Execution doesn't continue to the next case, so you don't need to explicitly break out of the switch at the end of each case code. You use for in to iterate over items in a dictionary by providing a pair of names to use for each key value pair. Dictionaries are an unordered collection, so their keys and values are iterated over in an arbitrary order. Experiment. Replace the underscore with the variable name and keep track of which kind of number was the largest. Use while to repeat a block of code until a condition changes. The condition of a loop can be at the end, instead ensuring that the loop is run at least once. You can keep an index in the loop by using double dots less than sign to make an array of indexes. Use double dot less than sign to make a range of that omits in the upper value, and use triple dots to make a range that includes both values. Functions and closures. Use func to declare a function. Call a function by following its name with a list of arguments in parentheses. Use the arrow to separate the parameter names and types from the function's return type. Experiment. Remove the day parameter. Add the parameter to include today's lunch special in the greeting. By default, functions use their parameter names as labels for their arguments. Write the custom argument label before the parameter name, or write to use no argument label. Use a tuple to make a compound value, for example to return multiple values from a function. The elements of a tuple can be referred to either by name or by a number. Functions can be nested. Nested functions have access to variables that were declared in the outer function. You can use nested functions to organize the code in the function that's long or complex. Functions are a first-class type. This means that the function can return another function and its value. A function can take another function as one of its arguments. Functions are actually in a special case of closures, blocks of code, that can be called later. The code in the closure has access to things like variables and functions that were available in the scope where the closure was created, even if the closure is in a different scope when it's executed. You saw an example of this already with nested functions. You can write the closure without a name by surrounding code with braces. Use int to separate the arguments and return type from the body. Experiment. Rewrite the closure to return 0 for all odd numbers. You have several options to write closures more concisely. When the closure's type is already known, such as the callback for a delegate, you can omit the type of its parameters, its return type, or both. Single statements closures implicitly return the value of their own statement. You can refer to parameters by name, by number instead of by name. This approach is especially useful in very short closures. A closure passed as the last argument to a function can appear immediately after the parentheses. When the closure is the only argument to a function, you can omit the parentheses entirely. Objects and classes. Use class followed by the class name to create a class. A property declaration in a class is written the same way as a constant or variable declaration, except that it's in the context of a class. Likewise, method and function declarations are written the same way. Experiment. Add a constant property with a let, and add another method that takes an argument. Create an instance of a class by putting parentheses after the class name. Use dot syntax to access the properties and methods of the instance. This version of the shape class is missing something important. Initialize it to set up the class where an instance is created. Use init to create one. Notice how self is used to distinguish the name property from the name argument to the initializer. The arguments to the initializer are passed like a function called when you create an instance of the class. Every property needs a value assigned, either in its declaration as with number of sides or in the initializer as with name. Use dinit to create the deinitializer if you need to perform some cleanup before the object is deallocated. Subclasses include their subsuperclass name after their class name, separated by a colon. There is no requirement for classes to subclass any standard root class, so you can include or omit a superclass as needed. Methods on a subclass that override the superclass implementation are marked to overriding a method by accident. Without override is detected by the compiler's error as an error. The compiler also detects methods with overrides that don't actually override any method in the superclass. Experiment. Make another subclass of name shaped. called circle that takes a radius and a name as arguments to its initializer. Implement an area and a simple description method on the circle class. In addition to simple properties that are stored, subproperties can have a getter and a setter. In the set of a parameter, the new value has the implicit name new value. You can provide an explicit name in parentheses after set. Notice that the initializer for the equilateral triangle class has 3 different steps. Step 1, setting the value of properties that the subclass declares. Step 2, calling the superclass initializers. Step 3, changing the value of properties defined by the superclass. Any additional setup work that uses methods, getters, or setters can also be done at this point. If you don't need to compute the property, but still need to provide code that's run before and after setting a new value, use will set and did set. The code you provide is run anytime the value changes outside of an initializer. For example, the class below ensures that the side length of a triangle is always the same as the side length of its square. When working with optional values, you can write the question mark before operations like methods, properties, and subscripting. If the value before the question mark is nil, everything after the question mark is ignored, and the value of the whole expression is nil. Otherwise, the optional value is unwrapped, and everything is after the question mark acts on the unwrapped value. In both cases, the value of the whole expression is an optional. Enumerations and structures. Use enum to create an enumeration, like classes and all other name types. Enumerations can have methods associated with them. Experiment. Write the function that compares 2 rank values by comparing their raw values. By default, Swift assigns the raw value starting at 0 and incrementing by 1 each time. But you can change this behavior by explicitly specifying values. In this example above, Ace is explicitly given a raw value of 1, and the rest of the raw values are assigned in order. You can also use a string to floating point numbers as a raw type of an enumeration. Use the raw value property to access the raw value of the enumeration case. Use the init raw value initializer to make an instance of an enumeration from a raw value. It returns either in the enumeration case, matching the raw value, or nil if there is no matching rank. The case values of an enumeration are actual values, not just another way of writing their raw values. In fact, in cases where there isn't a meaningful raw value, you don't have to provide one. Experiment. Add color parentheses method to suit that returns black for spades and clubs and returns red for hearts and diamonds. Notice the 2 ways that the hearts case of the enumeration is referred to above. When assigning a value to the hearts constant in the enumeration case suit, that hearts is referred but to by its full name because the constant doesn't have an explicit type specified. Inside the switch, the enumeration case is referred to by the abbreviated form hearts because the value of self is already known to be a suit. You can use the abbreviated form from any time the value's type is already known. If an enumeration has raw values, those values are determined as part of the declaration, which means every instance of a particular enumeration case always has the same raw value. Another choice for enumeration cases is to have values associated with the case. These values are determined when you make the instance, and they can be different for each instance of an enumeration case. You can think of the associated values as behaving like stored properties of the enumeration case instance. For example, consider the case of requesting the sunrise and sunset times from a server. The server either responds with the requested information or it responds with a description of what went wrong. Experiment. Add a third case to the server response and to the switch. Notice how the sunrise and sunset times are extracted from the server response value as part of matching the value against the switch cases. Use struct to create a structure. Structures support many of the same behaviors as classes, including methods and initializers. One of the most important differences between structures and classes is that structures are always copied when they pass around in your code, but classes are passed by reference. Experiment. Write a function that returns an array containing a full deck of cards, with 1 card of each combination of rank and suit. Concurrency. Use async to mark a function that runs asynchronously. You mark a call to an asynchronous function by writing await in front of it. Use async to call an asynchronous function, letting it run in parallel with other asynchronous code. When you use the value it returns, write await. Use tasks to call asynchronous functions from synchronous code without waiting them to return. Protocols and extensions. Use protocol to declare protocol. Protocol example, protocol. Var simple description string. Mutating func adjust. Classes, enumerations, and instructions can all adopt protocols. Experiment. Add another requirement to example protocol. What changes do you need to make to simple class and simple structure so they will still conform to the protocol? Notice the use of the mutating keyword in the declaration of simple structure to mark a method that modifies the structure. The declaration of simple class doesn't need any of its methods marked as mutating because methods on a class can always modify the class. Use extension to add functionality to existing type, such as new methods and computer properties. You can use an extension to add protocol performance to a type that's declared elsewhere, or even to a type that you imported from a library or framework. Comments. You can add comments to SQL queries using 2 hyphens at the beginning of a line. Just a test, select pointer from people, or use / *** to comment a portion of SQL inside the line, or to add multiple lines. Comments. Select pointer from / pointer / people. Select from test people. I think we've read everything. That person has not written so much. It's not a real big book like this, but you got a lot of books, of those small books. You got the Swift handbook, the Svelte handbook, the SQL handbook, what we just read, React handbook, Python handbook, PHP handbook, Node handbook, Next handbook, Laravel handbook PDF, JS handbook PDF, HTML handbook, GP handbook, Express handbook, CSS handbook, CLI handbook, C handbook. See what we've got. We have recorded for half an hour. That's quite a lot.